Okay, if you would turn with me to 52 on your notebook, we are going to look at proportions and ratio application problems and how to work those. So just go ahead and just date 52, date your page. And this time we're going to do a little different. You can just go ahead and write the title, Solving Problems with Ratios and Proportions. Okay, I'm going to divide this page into two parts. One of them is going to be on the ratio problem, and the other part is going to be on the proportion problem because there's a little bit of difference in how we work them. Do you remember yesterday what I said was the definition of a ratio? That's where we compare two quantities. We may compare them as like we did boys to girls in class. You may compare them as a fraction. That would be 2 to 10, or you could say it 2 to 10, or a third way is 2 colon 10. But all those are is just two quantities that we're going to compare. And a proportion, on the other hand, was a little bit different. It's an equation that says two ratios are equal. So whatever you've got on one side of your equal sign when you're doing your cross division, you have to, cross multiplication has to equal what's on the other side. So we'll get into that on the second part of the page. All right, for a ratio problem, I'm going to start out with a situation. You can just write ratio on the side, put a balloon, whatever helps you to see that. Let's say we have a fish pond, and somehow, some way, we know that there are 3,000 fish in that pond. Let's write down what we know. Pond has 3,000 fish. Okay. Somebody goes and gets a dip net, scoops up a whole bunch of fish, and what they find in their net is they have some catfish. In fact, they have 2 catfish. Then they have some perch. They count them and they have 5. And they also have some bass. They count them and there are 3. Okay, so what is our ratio or breakdown of fish in that pond? If we were going to write it in something like this, what would it look like? 2 to 5 to 3. That's the ratio of fish that's in that pond. It doesn't matter which order you put them in right now, as long as you know which number goes with which type of fish or which category. Okay, I'm going to go ahead and write this down here. Again, I'm going to write cat equals 2, perch or per equals 5, bass equals 3. That way I can work some math out beside those. Okay. Also, while we're talking about proportions, let's come up with some kind of equation where we could put all these types of fish together and have the total fish in the pond. So if we were to do that, we would need to have a variable. And we're just going to call it x. And that's going to be the number of each type of fish, or the number of each type of fish. I'm just going to put, right now, x equals fish. And that's regardless of what kind. Now, if we're going to figure out how much of each kind of fish is in the pond, we're going to do something like this. I'll move up so you can see a little better. Everybody got that? 2 catfish, so that's 2 fish, right? Plus 5 perch, still a fish, so I'm going to use the x. Plus 3x for 3 bass. It's going to equal what? 3,000, the total number of fish in the pond. Now that looks like a simple equation that I could solve for x, right? Let's go ahead and do that. So I've got 2x plus 5x plus 3x is 10x equals 3,000. So our X ends up being 300. Now, what is that 300? Does that tell us anything about the types of fish we have yet? No. That is just a number that we put with our ratio to see what types of fish we have or how many of each type of fish we have. Okay, so a while ago when I was saying 2x plus 5x plus 3x, that's going to translate to our types of fish. So to get the number of catfish that we have, what am I going to do? Well, why don't we just multiply by 300 right now? Yes, that's the fish. So out of the total, 2x, or 2 times 300, are catfish. And what does that equal? 600. Okay? If we follow that same procedure throughout, we'll have 5 times 300. It's going to be our perch, which equals 1,500. And then, same thing, 3 times our x. It's going to be our bass, which is going to be 900. Now, all of that better add up to what? 3,000? Okay. And it does, 3,000. So we've accounted for all of our fish, taking into consideration that our ratio of fish in the pond is 2 to 5 to 3. So whenever you have a problem like this and it gives you a ratio, always remember that you're going to multiply that times your variable, and then it should give you some kind of a total or sum. Just make it equal to the sum. Okay? So that's how you do the simple ratio problems. And we'll work out a few examples in a minute. Let me show you quickly how to do the proportion problems, and then I can answer any specific questions. Move this up a little bit. All right, right here somewhere that it's proportion, so you'll know what you're doing when you open your notes later. Okay, remember that a proportion is an equation that shows that two ratios are equal. So if you've got some known information, it allows you to use that known information to find the unknown. So here's the example I want to use for this one. We have a real estate agent. What do they do? Okay. Have a real estate agent that sells homes. And let's say that she sold a home that cost $100,000. She sold the home for that. Her commission, or her cut, on that sale was $6,000. That's what she was paid. That gives us a ratio, doesn't it? That gives us the cost of the home to the amount of the commission that she gets. Okay? And that equals, in this case, just for our known, a $100,000 home brings her $6,000. Pretty good cut. So that's the ratio. Now we've got to find another ratio that equals that. That's how proportion problems work. So let's see what else they have to say in the problem. Okay, now she's going to sell a second home. And it's sold for $230,000. Guess you know what I'm going to ask, don't you? What was her commission? Let's go back up and look at the original ratio and see if we can come up with a ratio that's equal that fits a new situation. The cost of the home over the commission, what should that equal over here? The cost of the second home over her second commission. I'm just going to put it like that. I've run myself out of room, so I'm just going to come over here, draw something that divides the two, and I'll finish it up over here. This is the main point you need to know when you're working with proportions. Whatever you do on one side, you have to do on the other side, and it has to be in the same order. So whatever's on top over here and whatever's on the bottom over here in the known situation, you've got to keep them the same way in the unknown. So we've got to look for the cost of the second home to calculate this X, which is the missing commission. So what was the cost of the first home? $100,000. And she got $6,000 from that. We're going to set that equal to the cost of the second home, $230,000 over X. That's what we don't know. That's what we're looking for. From here, the procedure you use to find that X is exactly the same as we've done with our cross multiplying. 100,000 X equals, it's going to get messy here because I'm running out of room, 230,000, can I just say K, is that okay with y'all? Times 6K, K being 1,000. Okay, so now what I have to do is what is 230,000 times 6? The big number. Just do that in your calculator and leave it there. So I've got 230,000 times 6,000 equals big giant number. Okay. Once I get that big giant number, which in my calculator is 138,000,000,000. One more. And over here I had 100,000 X. So how do I get X now? Divide by 100,000. So let's divide that by 100,000. And that tells us that for that bigger home, she got $13,800 commission. Okay? So you see how we used the known, which we had up here, to solve the unknown. Those ratios are equal. And if you go back and you divide 100,000 by 6,000, it should be the same answer as dividing 230,000 by 13,800. All your proportions are going to work very, very similarly to that.